So welcome back to 4.2 for MAT095. So we're going to be getting into writing fractions in lowest terms. So we saw a little bit about how we can find equivalent fractions by multiplying and dividing the top and bottom by the same number. But now we're going to go a step further and try to infer it and find those common numbers on our own. So let's see how that works. So the first thing we're going to do is define some terminology. So the first thing is numbers that are multiplied to give a product are called factors. So for example, if we were multiplying 2 times 3 to get 6, 2 and 3 are considered factors of 6. Whereas 4 times 3 is equal to 12, so 4 and 3 are going to be factors of 12. And we can always do that, and there's different combinations that we could always use depending on the size of the numbers. So not only are 4 and 3 factors of 12, but so are 2 and 6. So are 1 and 12. So there's all kinds of factors, but why I stopped at 4 and 3 was because of that overlap here. So because 3 is a factor for both 6 and 12, we can go a step further and say that that 3 is a common factor of 6 and 12. And that's the magic number we're trying to find in any given fraction. What's that common factor that goes into both the top and the bottom instinctually? And then we can divide it out to reduce it down. So the next definition, by simplifying a fraction so that the numerator and denominator have no common factors other than 1, then the fraction is in lowest terms. So that's what we're looking to do. So let's try a few and see how we do. So the first one, I want you to write it in lowest terms. So we have 15 over 25. So what's a common factor that goes into both 15 and 25? Well, 5. 5 should be sticking out at you. So now if you divide that 5 out, and then you're done. So 5 goes into the top 3 times, goes into the bottom 5 times. And that's it. You've reduced it to lowest terms. So what about 12 and 16? Well, because they're both even, you can always factor out a 2. So 2 would be a common factor, but it's nice to go bigger. So if you can go bigger, it's going to be better. But let's say you didn't know. Let's do it with 2. So if we divide the 2 out, we're going to get 6 over 8. But 6 and 8 are even. So we can divide out another 2. So if we divide out another 2, we get 3 over 4. So 3/4 would be our result. Now, could we have done that in one step? Sure. Instead of dividing by 2 twice, we could have divided the top and bottom by 4, and that would have got us to our answer in one step. So it's nice to be able to do it in one step, but it's not required. If you've got to do it in multiple steps, do it in multiple steps. Case in point, 24 and 36. We could divide out a 2. We could divide out another 2. We could divide out a 3. So we could do that one in multiple steps, but if we realize that 12 goes into both of those, we can do this in one step. So 2/3. Pretty quick. Ooh, here's another one. 84 and 108. And we got a negative that we don't want to forget about. So what can we divide out of those? Any ideas? Well, sadly, I think 12 works again. 12 goes into 84 7 times, and then 12 goes into 108 9 times. So if we don't forget the negative, we should get a negative 7/9. So, all right. What about 90 over 252? Ugh. I don't want to think about the biggest one. Let's do easy. Let's divide the 2 out first. So if we divide 2 out, what do we get? I'm going to go down here. 90 divided by 2 is 45. 252 divided by 2 looks like 126. All right, so that's a little better. But what goes into those? Here's a little trick for 3s. If you add up the digits and it's divisible by 3, then the overall number is divisible by 3. So 4 plus 5 is 9. 9 is divisible by 3. So we should be able to divide a 3 out of here. And 1 plus 2 is 3, plus 6 is 9. So we can divide 3 out of there too. All right. So 3 goes into 45 15 times. 3 goes into 126. It looks like 42 times. All right, well, we're getting there. Well, 1 plus 5 is 6. 4 plus 2 is 6. So we can divide out another 3. So it looks like we get 5 over 14. 5 over 14. Now, how do we want to do this in one step? Well, 3 times 3 is 9, times 2 is 18. We would have had to divide 18 out of the original fraction, and that would have got us to 5/14 in one step. So, but oh well. What about the last one here? 10 out of 13. Yeah, there's nothing. There's nothing that goes into both of them. There's no common factor. So in this case, you do want to write something for your answer. So you can write it one of two ways. I would write in words in lowest terms, or you could say 10 over 13 equals 10 over 13. That kind of shows me that you can't do anything with it. But don't just write 10 over 13 and nothing else with it, because I don't know if you're writing the problem down or if that's your answer. So definitely show something that kind of indicates what the answer is. All right. So let's take a look at the next page, which gets into other ways that we can reduce fractions down. So again, it builds off some terminology that you might have heard before, but if not, hopefully it'll make sense once we go through it. And then we'll take a break, and then we'll get the rest of it in the next video. So if common factors are not easily seen, then another way to write the fraction in lowest terms is by writing the numerator and denominator as a product of prime numbers. Prime numbers. Okay, so a prime number is a whole number greater than 1 that has only factors of 1 and itself. Okay, where a composite number is a whole number greater than 1 that is not prime. Okay, so it deals with the factors. It's got to have no interesting factors. It's going to have boring ones if it's a prime. So, well, let's do example 2. So it says, which numbers of the following list are prime, composite, or neither? So 0. Well, the criteria says it's got to be greater than 1 either way. So this one is going to be neither. Can't be either one. What about 9? So is that prime or composite? Well, it's got numbers that divide into it other than 1 and itself, right? 3 goes into that. So right off the bat, it would have to be composite. What about the number 1? Well, again, greater than 1. So that is kind of a silly one as well. That's neither. 23. So what numbers go into 23? Is there any? No, there's nothing that goes in. So that one's got to be prime. 40. Well, it's even. If it's even, then 2's got to go into it. So that's going to be composite. 8. 2 goes into that. 15, well, 3 goes in, 5 goes in. So definitely more than just 1 in itself. What about 19 though? Yeah, 19 is going to have to be prime because nothing else goes in. And then 33. Yeah, 33 is composite. It's not going to be prime because 3 goes in. So, all right. So we have kind of an understanding of what looks prime and what's not prime. Now, just for reference, let me just write a little list of prime numbers. So the first prime number, which has to be greater than 1, is actually 2. 2 is the first prime number. Nothing else goes in. And then 3 would be next. Can you guess the next one? It's going to have to be 5, then 7, then 9. Oh, no, 9's composite. So we got to skip 9, not 10. 11, though, would be. 11, 12, no. 13, yeah. 14, no. 15, no. 16, no. 17, and 19. And it just keeps going on forever and ever. Now, they do have a list in your textbook, so I think it's got the list up to 100 of all the primes, I think. So you can reference those if you want, but you really shouldn't have to go too far in the primes for what we're going to use them for. So, all right, let's stop here, and then we'll see how to use these prime numbers to reduce fractions down in the next video. See you in a minute.